Yo, what's up, Sci Fam? It's your boy Nickel here, and today we're going to talk about the development of the brain. So, there's too much information to fit onto one page. So, as you can see, I had to use two different pages. You can just go with the flow here and, leave yourself some space, but it might take a couple pages to cram all this info in. So, we need to title our page Brain Development. Let's get started. To begin with, let's just remember the cell structure of a brain cell, and that is called a neuron. So I've got kind of this larger end down here on the left side, which I'll draw some other little projections coming from it to show that this is the dendrite. This is the area that receives the signal. Remember, it's got the cell body in here, so there would be like the inner cell parts, and I could even draw the nucleus in there. And then we have those fats that run and create like a sheath on this axon, and these fats are called, that's right, you guessed it, myelin. So we've got this myelin sheath, which is just a bunch of fats that help speed up the signal as it travels down the neuron. And then down here at the end, we have our axon, which has all these projections here to transport those neurotransmitters that we discussed. But the reason I want to bring up the neuron again is because I want to label some different parts here of the neuron. Because today we're going to be looking at the difference between gray matter and white matter. And so when we think about a neuron, there's a certain part of a neuron that makes up all of the white matter in our brain, and another part of our neuron makes up the gray matter that's in our brain. So the gray matter is basically the cell body, so it's this part here, and it's also going to be this end part. So this would be our gray matter and gray matter. So go ahead and label that as you drew your neuron. And this middle part that's sheathed in myelin, that myelin actually gives it a white color. So this is our white matter. Now, as we know, the signal gets sent from the cell body, the dendrite, down the axon to the axon terminal. So this part in the middle with the myelin on it actually is important for transporting information. So the more myelin you have on your neurons, the easier it is for the signal to travel down that pathway. So if you're really good at something, like as you learn how to juggle more and more and more, what your body is doing is it's adding more and more myelin onto your neurons because you keep practicing it, and so your body starts to adapt and say, hey, we're going to use this all the time, so let's make sure that it works really, really well. So your body keeps adding myelin. So when you learn something, you actually are increasing the amount of white matter as you continually do something over and over again. So let's talk about gray matter and white matter and define each of those types of things. So like I said, the gray matter is just basically the cell bodies, which is essentially the soma. It also includes the dendrite area of the neuron. So it includes all of our dendrites. It also includes our axon terminals, because that's where that axon ends, at the end there on the far right side. So the cell bodies, the dendrites, the axon terminals, and even the synapses, which are the areas between the neurons. And so if we take a look at inside somebody's nervous system, you can actually see the gray matter and the white matter, and we'll take a look at that in class. So when we see gray matter, what we're looking at is all the cell bodies, the dendrites, the axon terminals, and even the spaces between the neurons, the synapses. So if we think about those parts of the neuron, we end up having more of these at about 11 to 12 years old. So it increases at 11 or 12 years old. It also increases when you're born. When you're born, you have more gray matter. You have more cells in your brain as a young child than you do as an adult. Because kids have to be able to learn a bunch of stuff. And so all these cells are there so that they have the potential to draw connections between things. But as we draw connections between being hungry and crying, that continually gets practiced over and over again because we use it multiple times. And so we myelinate that connection over and over and over again. So that's how we learn. So gray matter increases at 11 to 12 years old. Then there's a 1% loss. So we start to actually get rid of all those cell bodies and dendrites and axon terminals. We lose it at about 1%. So it increases at 11 to 12 years old, but then there's a 1% loss of gray matter. Every single year we lose 1% of it until at least 15 to 16 years old. And we call this process of getting rid of all these cells in our brain, we call this pruning. So we're literally pruning our brain. So if you don't use part of your brain, maybe as a young kid you learned German or French or Arabic, but if you don't use it, then your brain literally gets rid of those cells because they're not needed anymore because you're not using them anymore. And so we call that pruning. So we end up increasing the amount of gray matter or cells in our brain. It flattens out until we're about 11 or 12. It increases at 11 or 12 just for like a year or so, and then it just starts to plummet, and it goes down and down and down and down and down until we just have the cells that we use most often, and that's into our 20s that we finally, our brain is using the certain types of cells. So most pruning happens in an area of our brain, and that area is in the prefrontal cortex. So you can think about what happens in our prefrontal cortex. And as you know, in that prefrontal cortex, that's going to be like where our decision making and our planning, our memory, our prioritization, our organizing, all that stuff is in our prefrontal cortex, and that's where we start to lose a lot of those cells. Most of that pruning happens from 11 and 12 to about 15 or 16 years old. We get rid of the cells that we just don't need anymore. So we're finally mature at 15 to 16 years old, and I'm just going to use an abbreviation, YO, for years old. So our brain is mature at 15 or 16, unless we're in a social situation, then we lose the capacity to use our prefrontal cortex, or if emotions are involved. So imagine if you're trying to make a decision. If it's a social decision or an emotional decision, we completely lose the functioning of our prefrontal cortex if we're 15, 16, 17, 18, 19, 20. Once you get over 20, then your brain actually starts to mature, and it can actually handle the extra stress from social situations and emotional situations to make those decisions. All right. The white matter. The white matter is different. It's the axon that's layered in myelin. So we'd say that the white matter is bundles of myelinated axons. And these are useful for conducting signals between neurons. So as we use neurons more and more, our body puts myelin on them so that they can conduct signals between them, and these relate to behavior and learning. So as we learn something, we add more and more myelin. This is called a neural network. So as you all are practicing your juggling and gaining some skills with juggling, your body is myelinating the neurons that are useful in juggling. And if you continue to juggle year after year after year after year, then that myelin will become stronger and stronger, and it will become thicker, and it will allow you to just do it as if you were just like riding a bike. But in order to learn how to ride a bike, you had to gain that white matter. That's why we say it's like riding a bike, because a lot of people do it when they're young. They continue to do it year after year after year. So we use that analogy because your body usually has pretty good myelination on those neurons that are involved in riding a bike. So the white matter in your brain, that myelinated axons, they increase from age 11 to 12. I'm going to use that YO again as an abbreviation for years old. So it increases from 11 to 12 years old into your 20s. And since we get rid of all that gray matter through pruning, we get rid of a lot of cells. But what replaces that space that's lost when we get rid of the gray matter is this white matter. So it increases from age 11 to 12 years old into our 20s, filling the volume lost because you lose volume or space from pruning. Now, if you're a little confused by this, I thought that it'd be best if we could just draw some graphs here to show how we increase or decrease the amount of white matter or gray matter in our brain. And so we're going to look at how this occurs over the course of our lifetime as we age. And so if we have our age here as birth, and we put 0 here on the x-axis as our age, we're going to take a look at what happens to white matter when we are 11 to 12 years old, when we're in like our 20s, and then when we're like 30 plus. So as I said, white matter increases. It then starts to flatten out until you're 11 or 12. At 11 or 12, the amount of white matter actually dips real quick, but then it goes up into your 20s, and then it flattens out as you're 30. So the biggest places of learning then, we learn the most when we're really young, and as teenagers, we learn the most because those are the areas that have the most increase in their slope. All right, you don't need to highlight your lines, but you do need to draw these graphs here. Now, gray matter is a little different. We're going to put age 2 in here. We'll add age 11 to 12, and then we'll add that whole 30 plus, like when we're finally mature. So from 0 to 2, the amount of gray matter in our brain, the number of cells in our brain increases rapidly. But then at 2 years old, it starts to decrease, and it goes down and down and down. It kind of levels out at 11 or 12. We get a little slight boost, but then it decreases. And by the time we're 30, we have almost half the number of cells in our brain that we did when we were born, or at 2 years old, because we don't need all of that. And our body finally realizes by the time you're 20 or 30 years old which ones you actually need. So you can see that the paths are very different between white matter and gray matter in terms of how it increases or decreases. So gray matter is all the number of cells in your brain. The white matter is what connects all those cells together through our axons. And so the more and more you learn, the more you use stuff, the more and more white matter you gain. As you stop using stuff, we get rid of the gray matter because we don't need it anymore.